Today we are going to learn about something called the zeros of a quadratic, and we're going to look for relationships between that and something called factored form. So let's start with the warm-up. Factor the following quadratics. For the first one, it's a trinomial, and you want to check is there anything you can factor out of all three terms, and there's nothing. So we're going to put it in our box and circle right here, and we'll have x squared, we'll have 10x, and we'll have 24. We want to know what multiplies to the first two terms. 24x squared, that adds, I should put m here, that adds to our middle circle here, 10x. So two things that multiply to 24 that add to 10 would be a 6x and a 4x. And then we're going to get the outside of the box by thinking what multiplies to x squared, that would be x and x. X times 6 is 6x, x times 4 is 4x. So the two factors of this trinomial are x plus 6 and x plus 4. If you wanted to check your answer, you could multiply this out, and you should get what you started with. For the second one, you should notice it's a pattern, difference of squares. If they're both square numbers being subtracted, you can take the square root of each one. So the square root of x squared is x. Put your plus and your minus. The square root of 25 is 5. And again, if you wanted to check your answer, you could multiply that out. So first question here in the notes, what is the shape of the parent function y equals x squared? This is a function that we looked at in first semester when we looked at shifting functions up, down, left, and right. X squared is a parabola, and we should know a few things about parabolas. It's a U-shaped graph. The vertex, or where it changes direction, is at 0, 0. There's a line of symmetry at x equals 0. And again, you can shift that up, down, left, and right. You can put a negative in front of it to make it upside down, like these parabolas that you see in Angry Birds. Where might you see something parabolic in real life besides Angry Birds? Anything with projectile motion, anything that goes up and then comes back down, that's parabolic. And where the parabola crosses the x-axis, that's called several things. It's called the x-intercepts. It's called the zeros, because it's where x equals 0. It's called the roots, or you might see it as the solution. So you might see these terms interchangeably, and what they're asking for is, where does it cross the x-axis? So we're going to look at an investigation date finding the zeros. For each of the following problems, factor the quadratic. Type it in your calculator. Use ZoomFit to see the graph. Look for the zeros, the solutions, the x-intercepts of the graph, and then look for relationships between your factored form and your graph. So let's do the first one. Let's factor x squared minus x minus 6. Let's use a box and circle. We have x squared, we have negative x, and we have negative 6. And we want to know what multiplies to negative 6x squared. That adds to negative 1x. So what multiplies to negative 6 that adds to negative 1? That would be a negative 3x and a 2x. And then if we find what multiplies to each of the terms in the box.
The 9th grade bar meeting is now starting in C350.
X times x is x squared.
The 9th grade bar meeting is now starting in C350.
X times negative 3 is negative 3x, and x times 2 is 2x. So these are the two factors, x minus 3 and x plus 2. They're factors, they multiply to x squared minus x minus 6. All right, let's sketch this in a graphing calculator and see what it looks like. So you can open a new document, add a graph page, and let's type it in. X squared minus x minus 6. And if you take a look at it, let's sketch a graph. Look for the zeros. One zero is at 3 and 1 0 is at 2. And the y-intercepts down here at like negatives. Negative 6 about. Okay, so we had one at negative 2, a 0 at negative 2, 1 at 3, 1, 2, 3, 4, 5. So this is about the sketch of our graph here. All right, what do you notice about the factors and about the zeros? So this 0 is at 3 and this 0 is at negative 2. Well, 3 is the opposite of negative 3. Negative 2 is the opposite of 2. So you could write something about that here. They're the opposites of the factors. Let's try it again and see if that pattern holds true. So let's again factor. We have x squared minus 4x minus 5 in our box and circle. So we want to know what multiplies to negative 5x squared that adds to negative 4x, and that would be negative 5x and 1x. They add to negative 4, multiply to negative 5. Let's get the outside. X times x is x squared. X minus 5 is negative 5x, and x plus 1 is 1x. So here are your factors, x minus 5 and x plus 1. Let's type this in. So here we can hit tab to go back up and type in our new function. It was negative 5x, no, negative 4x, I think. Yep. Negative 4x. Oops. Here's x, and then minus 5. All right, look for where the zeros are. They're at negative 1 and at 5. Negative 1, 1, 2, 3, 4, 5, and then the y-intercept's somewhere down here. So here's my sketch. Again, what do you notice about the factors, which are at 1, negative 1, and 5, and the zeros? Well, they're the opposite of the zeros, of the factors, I should say. So the zeros are the opposite of the factors. Okay, let's try a few more here. We did those. Okay, x squared minus 16. Okay, we know how to factor this as difference of squares. We have x plus 4 and x minus 4. So make a prediction. What do you think that the zeros will be? Probably the opposite of the factors. So again, if we use our calculator, hit tab, go up, and it's x squared minus 16. And again, we have zeros at negative 4 and at 4. And I can't see the y-intercept is somewhere below here. So again, what do you notice about the factors and the zeros? The factors are the opposite of the zeros. Okay, let's try one more. Let's factor this. We can pull a greatest common factor out of this. Let's pull out a negative 2. And if we, in negative 2x, we can pull out. And if we do that, we get x minus 5. And we can't factor that any further, so let's go ahead and type this in and see what's happening. So hit tab. All right, so here it's negative 2x. Oh, I did 5. Oops. Let's try it again. Negative 2x parentheses x minus 5. It's not letting me do that. Let's open a new page. Maybe I screwed something up here. All right, let's try it again. Negative 2x x minus 5. Okay, let's put in the original function. It should work. So again, let's open a new document. Okay, so let's type in the original function, which I was doing for all the rest of them anyways. Negative 2x squared plus 10x. Negative 2x squared plus 10x. Oops, let's go back here. Plus 10x. All right, we have two zeros here. One's at 0 and one is at 5. And you can see that one is from, okay, let's type it in. One is at 0, 1, 2, 3, 4, and one is at 5, and you can see that it's upside down. That's not graphed very well. So something like that. What do you notice about the factors and the zeros of the graph? Well, it's the opposite of this one, but then one of the factors is also 0. So let's talk about this rule, this pattern that we're kind of finding. Summary, to find the zeros of a quadratic, you can factor it and see what makes it equal 0. So you can factor it and then see what makes each factor 0. to find the opposite of the factor. So what I mean by that is here we factor it, and let's see what makes negative 2x equals 0, and what makes this other factor x minus 5 equals 0. Well, here, if we solve for x, we divide by negative 2. So one of our factors is at 0. And one of our factors is the opposite of negative 5, or at 5. And the reason is 5 makes this a 0. So again, we're looking for where this is 0. We can set each equal to 0 and solve. Let's try another one. Let's find the zeros of this without graphing. Let's factor it. So you can use your box and circle. If we do that, we want to know what multiplies to negative 24. That adds to 5. And that would be x plus 8, x minus 3. So I skipped putting in a box. But if you put in a box, this is what you should get. And we want to know what makes this equal 0. Well, using zero product property, if each one of these factors is 0, the whole thing is 0. So if x plus 8 equals 0, the whole thing is 0. Let's solve. One of our zeros is negative 8. What makes x minus 3 equal 0? Because if this is 0, 0 times anything is 0, and this whole thing is 0. So here, if we were to graph this, we would have two zeros, and one of them would be at 3, and one would be at negative 8. 1, 2, 3, 4, 5, 6, 7, 8. And it would look something like this. That's not a very good sketch, but something like that. So the first part of our notes today, if you factor something, set each factor equal to 0, you will find the x-intercepts, or the roots of the function. All right, so let's use that property to write the equation. So to write the equation, first up, find the x-intercepts. So right here, the x-intercepts of this is about 0.5, negative 0.5, I should say. And this one's about 2.5. So to find the equation of the graph, we can write, okay, so those are the x-intercepts. To find the y-intercept, that is right here. 1, 2, 3. So it's 0, negative 3. All right, so to put this all together, what we're going to do is we're going to write this equation. Y equals, there might be a scale factor here. It might be skinnier or wider, so I'm going to put A. I don't know what that is. But then we have our the zeros, and it was the opposite. So x minus 2.5, x plus 0.5. To figure out what A is, we can plug in this point, this y-intercept, so this is x and y. Let's plug that in and let's solve for y, or solve for A. So we have negative 3 equals A, and then I'm going to plug in a 0 here and here. So negative 2.5, 0.5. I'm going to multiply these together. So let's use scratch pad. And it was negative 2.5 times 0.5. And that's negative 1.25. So you have negative 3 equals A times negative 1.25. We'll divide each side by negative 1.25, and I'm out of room here, but divide by negative 1.25. So in our calculator, we'll do 3 divided by negative 1.25, and we get negative 2.4. So the equation of this graph, so that's what A equals. The equation of this graph would be negative 2.4 times our x-intercepts, the opposite of them, so x minus 2.5, x plus 0.5. If we were to try to type this in our calculator, we should get this right here. All right, let's try another one. Let's identify the x-intercepts and the y-intercept, and then we can write the equation of the graph. So the x-intercepts are 1, 2, 3. So I should say x equals negative 3. And this is about x equals 0.5. The y-intercept is 1, 2, 3. So again, negative 3. And again, we're going to plug into this equation. Y equals A, that's what we have to figure out. And then we do the opposite of the 0. So x plus 3, x minus 0.5. We're going to plug this point in for x and y. So we have negative 3 equals A times, and here the x's are zeros, so we have 3 times negative 0.5. All right, now we solve 3 times negative half is negative 1.5. Divide each side by negative 1.5. So here the a value, or slope, we kind of called it first semester, is -3 divided by -1.52. So a equals 2. Let's rewrite this equation then. Y equals 2 times x plus 3, x times x minus 0.5. And this would be the equation of our quadratic. Okay, let's try a few more, and this is what you'll practice today. So first of all, x-intercepts here, it looks like they're at 4 and at 1, 2, 3, 4, -4. The y-intercept is 0, -16. Let's write the equation. Y equals a times x minus 4, it's the opposite of this one, x plus 4, the opposite of this one. Let's plug in our point here. -16 equals a times, plug in zeros here, -4 times 4. -16 equals a times -16. Divide each side by -16, so here a is 1. So the equation of this function is y equals x minus 4, x plus 4. And you could put the 1 out in front, but you don't need to. Okay, last one. The x-intercepts, there's only one, and it's at 3. And since it does bounce back up, there's actually 2 of them here. So we have x minus 3, but there's 2 of them, it bounces back up. And then the y-intercept is, it looks like 9. Let's write that right here, 0, 9. So let's plug in our x and y. So 9 equals a times 0 minus 3 squared. 9 equals a times 9. So here again, a equals 1. So your equation is y equals x minus 3 squared. Okay, so again, 2 rules today. The first one is if you can factor a quadratic and then set each factor equal to 0, you'll get the x-intercepts. The other rule we looked at is if you have the zeros, you can write the factors as the opposite. You can plug in a point like the y-intercept, and you can write the equation.